In this tutorial, you'll learn how to write numbers in scientific notation and convert them back into standard form. The learning target for this lesson is that you can convert numbers between scientific notation and standard form and eventually compare their size. By the end of this tutorial, you should be able to recognize that positive powers of 10 are larger numbers and negative powers of 10 will represent smaller numbers. You also need to understand that the place values represent the powers of 10. And finally, you'll need to check that your coefficient is between 1 and 10. It can be equal to 1, but it must be less than 10. It has to have a single digit in front of the decimal when writing in scientific notation. And you need to recognize that sometimes that means you need to change the coefficient and the power in order to be properly written in scientific notation. All right, let's get started. Please note that place values are written as powers of 10 when talking about scientific notation. And notice that the negative exponents do not represent negative numbers. They represent place values that are lower than 1, like the tenths, the hundredths, and the thousandths. This number is written in standard notation, and the second number is that same number but written in scientific notation. So scientific notation is a way of taking a value and writing it in a shorter way, maybe leaving off these extra zero place values and using just these non-zero digits at the beginning. You see my coefficient here, 2.93? That comes from the original number, 293. So the digits remain the same, but all of these place values here, we're going to remove them and we're going to shrink the number down to this shorter coefficient. Now the number of zeros you have is not going to be your exponent. All right, your exponent is going to be determined by how many places, that's what the number 10 represents, how many places you move your decimal point. So I know you don't see a decimal point here, but it's hiding at the end. And if I want my number to be between 1 and 10, then I want to move that decimal until I have just one digit to the left. You see that? I have one digit to the left of the decimal point. So the question is, how far, or how many places, I should say, how many place values do I need to jump over in order to get to the front of this number? Now notice I don't go all the way to the end. I stop as soon as I hit my first non-zero digit. That's between 1 and 10. So look, I moved 1, 2, 3, 4, 5, 6, 7, 8, 9 place values, and that's why my power is 9. All right. One thing you need to know is that if your power of 10 is positive, that means you started with a really large number. And if your power of 10 is negative, that means you were starting with a really teeny tiny number. Now, I know that number's long, but it's actually really small because it's a decimal value. So large numbers will have positive powers of 10. Large numbers. Small numbers will have negative powers of 10. Okay, so negative powers are not negative numbers. They mean you have really teeny tiny small numbers. All right, let's review this concept. I have the number 3.6 times 10 to the 5th. Remember, my power of 10 is positive. So does that mean that the number would be larger if I wrote it out in standard form, or would it be smaller? So let's think about this. I'm going to multiply 3.6 times 10 to the 5th, which is a 1 with 5 zeros. So if I multiply 3.6 times 100,000, that number is going to get bigger, of course. And I know that it's going to be larger because the power of 10 is positive. So if I asked you, would this number be larger than 1 or smaller than 1 if written in standard form? you should respond larger. Let's take a look at the next question. Larger or smaller? Larger, because the power of 2 is positive. How about this third one? Hopefully you answered negative, right? That's a -6, so that means it's going to be smaller. Let's go a little bit faster. Larger, smaller than 1, smaller than 1, larger than 1, smaller than 1, larger than 1. All right. Now how about if I reversed it? If I have this really small number, do you think that the power of 10 would be positive or negative? The answer here for A is negative, because the only way for this small number to be written in scientific notation is if it became bigger and became the number 5.0. And in order to do that, I would have had to move my decimal point 2 places. 2 places from that negative direction. So the answer is the exponent would be negative. How about this one? That's a large number. So large numbers have positive powers of 10. So the answer is positive exponent. This one's smaller than 1, so it would have a negative exponent. This one's larger than 1, positive exponent. Positive exponent, negative exponent, negative exponent, negative exponent, positive exponent, positive exponent, positive exponent, negative exponent. All right. Now this is how a scientific notation number must begin. It must have a front number, known as the coefficient, that is between 1 and 10. Now it can be equal to 1, but it has to be lower than 10. So if I had something like this, that would be too big. My digit can be 2, but it can't be 27. All right, so the front number here has to be a number between 1 and 10. And it can have as many numbers as we want after the decimal. It can be short, it can even be a 0, or it can be long. But what it won't have is all these zeros. Now your power of 10 can be positive or it can be negative, depending on what type of number you have, large or small. All right, let's see how you understand scientific notation. Remember what your coefficient has to be in between? 1 and 10. And do you remember that your power has to have a base of 10, right? So this coefficient has to be between 1 and 10. This number has to be a 10. And there has to be a times sign in the middle. So let's check to see if you know which one of these, or which of the following, maybe there's more than one, which of the following are written in scientific notation. Think carefully. Pause the video. All right, let's check your answer. The only correct answer was C. And that's because this number has a coefficient that's higher than 10. This one has a base that's higher than 10, right? That says 100. And this one has a coefficient that's less than 1. You can't have a 0 to the left of the decimal point. All right, let's try this one more time. Which of the following are written in scientific notation? Again, there can be more than one answer. All right, pause the video. Let's see how you did. Both A and B are correct. All right, in order to convert a standard number into scientific notation, you need to take the decimal point and move it in between the first two non-zero digits to get 7.8. Leave all of the other zeros off. Now write your time sign, write your 10, and now choose the correct power. The power is going to be chosen by determining how many digits you had to jump over to get the decimal between the 7 and the 8. We had to jump over 4. Now it's a positive 4 because my starting number was bigger than 1. See, that's a big number, and big numbers have positive powers. Let's do the next one. 609, the decimal needs to go to the front here. 6.09 times and a 10. I had to move 2 place values to get there, so my power is 2. Next one, move it to the front here to get 3.9. Write a time sign and a 10. I had to jump 1, 2, 3, 4, 5, 6 places to get there. Now this one here, I can't move the decimal to the left because if I did that, I would be lower than 1. So it looks like I don't even need to move this one. Don't move it at all. That's a move of 0. All right, let's try these negative ones over here. This is a really small number, so I'm going to have a negative power of 10. The question is, what will that power be? Well, I need to take this decimal point and move it until I get a number between 1 and 10. 5.4. 1, 2, 3, 4, 5, 6 numbers I had to pass to get there. This one's going to move between the 4 and the 5. And I have to 1, 2, jump over 2 numbers to get there. Remember, that's a negative 2. This one needs to move 1 place. 10 to the negative 1. And this one needs to move 1, 2, 3, 4 places. 10 to the negative 4th. That is how you convert a standard number into scientific notation. All right, let's do the reverse. If you have a positive exponent, then you're going to have a larger number. If you have a negative exponent, you're going to have a smaller number. So remember that. Positive powers mean the numbers get bigger. Now, I'm going to get 5 places bigger, not 5 zeros bigger, 5 places. So that means 4 takes up the first place. 2, 3, 4, 5. See all those loops? 1, 2, 3, 4, 5 times I need to move that decimal. And if you run out of numbers, you put zeros in those places. So I actually am going to have 4 zeros after I move, because this 4 took up one of my places. So the answer is 540,000. Number 2, let's get 8 places bigger. Well, here's 1, 2, 3. 1, 2, 3 places. Now I've got 5 more to go. 1, 2, 3, 4, 5. That's a big number. This one is going to get 0 places bigger, so no changes at all. Now for the other side. These are going to get smaller. Again, 3 places smaller. 1, 2, 3. And if you run out of digits, you fill them with zeros. Again, 7 places smaller. Well, this takes up 1 place. That puts me here. But I've got 6 more to go. So instead of making loops, I'm just going to make zeros. 1, 2, 3, 4, 5, 6 more places to go. This last one gets 1 place smaller. That leaves me with 0.48. So rewind this video, check those answers over again if you need to, or give it a try on your own. All right, I'm going to review a couple more questions from both of these topics with you. I'm going to do a few random questions here. I want to take my standard number and I want to write it in scientific notation. That means I'm going to need a time sign, a 10, and a power. So let's do this one here. 1, 2, 3, 4, 5, 6 digits I need to pass in order to get to that front number. So I need all of the digits except the zeros at the end. So 1.852. It's 10 to the 6th because I moved 1, 2, 3, 4, 5, 6 place values in order to get my new coefficient. Let's do another one. 4,671. 1, 2, 3. Need to move 3 places to get to the front of this number. Now how about these little numbers down here? Looks like I'm going to need to move 1, 2, 3 places to get between the 9 and the 8. But because my number was small, it's going to be a -3. How about this one? 1, 2, 3, 4, 5, 6. 6 places to get between 1 and 4. This one moves 1 place. And this one moves 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, let's convert the opposite way. Let's turn these scientific numbers back into standard form. So these have positive powers, so these numbers are going to get larger. You see that? But these numbers down here have negative powers, so they're going to get smaller. So it's good to have an understanding of those positive and negative powers. All right, this one's going to get 3 places larger. 1, 2, 3. Don't forget to fill in that placeholder 0, right? So the decimal point is now at the end. This one's going to get 5 places larger. So let's see. 1, 2, 3, 4, 5, right? 1, 2, 3, and then 2 empties. (9.82 times 10 to the first), that's going to get 1 place value larger. 98.2. Now let's try some of these negative ones. This one's going to get 5 place values smaller. But again, when I move, this takes up 1 place. I've got 4 more to go. 1, 2, 3, 4 zeros, 5, 2, 5. And the decimal goes in the front this time. This one's going to get 7 places smaller. So these remain, and then I move 1, 2, 3, 4, 5, 6, 7. This one's going to get 2 places smaller. 1, 2. And that concludes the lesson on converting between scientific and standard notation.